Lecture, as I announced now, will be concerned in more detail with the change in chemical composition of the fruit itself during the growing season and finally during the ripening period. Now each of you should have a handout pertaining to this particular transparency that I have on the screen. You do have one?
He asked me for it, yeah.
Oh. Is there any one that's short? We have more if you need them. All right.
There were just two.
There are two at the present time, yes. We'll start with this one first. This one here, of course, pertaining to the soluble solids and particularly the sugars in the grape. This variety happens to be white Riesling. We can certainly interpret these results in a general way for all of the varieties, although certainly the proportions of these could change slightly, and even the slope of the curve could change somewhat depending on the temperature, the heat summation rate, and on the crop level on the vine and such variables as that. But generally speaking, during this period in here, I do want to caution you now, we're working on two very different scales here. When they put total acid in, we're looking at a value here of about 1% to 2. Not even that much here. And of course here on your degree bricks, which goes up to, in this case, about 22. But at any rate, the familiar pattern of the acidity, which we talked about the other day, being quite high until early part of the season and then drops off with the advancing of the season. And we'll have more to say about that a little bit later. Now let's focus our attention on to the total soluble solids, this familiar curve where you have this very rapid increase in soluble solids on up and then tapering off as you approach 20, and for practically all grapes it would flatten out at around 25. Now within that total acids, of course, we have two sugars that are dominant, fructose and glucose. In fact, we can say they make up almost entirely the total sugar content of the soluble solids. There are very, very small amounts of sucrose in grapes, usually less than 1%. So we can focus our attention then on these two. In most grapes, they are present about 1-to-1 ratio. You notice here towards the end of the season, the glucose in this particular case went down considerably and the fructose appeared to increase. But there again, if we interpret a general curve, we could say they would come out pretty much at the same level, about the same amount in the case of each of your monosaccharides. Now, there are questions at this point. Yes?
What percentage did you say that the total acidity was?
Well, back here, this isn't, I'd better reserve our critical comments on total acidity until we get to the slide pertaining to the acids. We can study that a little more in detail. It simply is put in here because it is a component of the soluble solids. It represents quite a proportion of it, as you can see here. And that's one of the reasons for the basis of that question yesterday, why the error can be much greater on green grapes than ripe grapes in interpreting the total soluble solids as the percent sugar in the grape. And of course, it will be as high as 2 or 3% in the very small berry in the green stages, and then of course decreasing during the season. In cooler areas, it may remain as high as 8 or 9/10%. And in the very hot districts, particularly with table and raisin grapes, it may even go down to as low as 0.5. In fact, there are wine grapes that will go that low too. And in the meantime, you have, of course, this soluble solids up in the order of 20, 22, 24, even 25 degree bricks. And of course, you can see here that interpreting a 24 degree bricks reading in this grape over here, there would be very, very little error in calling it sugar. Only this perhaps a 2% error, or even less than that. Whereas back in here, of course, it could be a 50% error at certain stages. Now, the stages of growth, we call this essentially, or arbitrarily, this first green stage here, the hardberry stage, a stage of growth. Then that veraison at about 10-degree Brix, right in this point, we're on the steep part of the curve. When the berry starts to soften, the deep green color starts to change to a slightly more yellowish tinge, and in the case of our black or red varieties, the very first evidence of pigmentation. Here we have the appearance of the anthocyanins, and we'll talk about that later. And then continue berry softening, rapid increase in sugar, and then culminating in the mature stage of the fruit. These so-called stages are quite arbitrary, and I don't make much of a point of them, except to recognize you have cell division primarily down in this stage, and then you get into cell enlargement that accounts for growth, and the growth is a little ahead of this before the sugar starts to accumulate. Yes?
Why would your total soluble solids drop there at the top? Because all the peaks in the fall off.
You mean this little hook in this? Oh, that would be sample error. It could be any number of things. That would be my interpretation. Because it isn't normal for the total soluble solids to drop, except you can get daily or diurnal fluctuations to some extent based on the irrigation program. It's true, if you irrigate a vineyard heavily, say at about this stage up here, you could get a little dilution there temporarily because of a rapid intake of water, particularly if the vines have been not necessarily under stress, but the water content of the soil is down fairly close to the wilting percentage. Then you can get some dilution effect there. But I would suspect in this particular case it's a sampling error. Now, I don't think this is, and I don't have a good explanation of why this rather sudden final sampling here would show that drastic change. There could be some sampling error there in changing, you see, from about the... And it's characteristic of that variety, of course, to have a slightly lower glucose than fructose.
Glucose and fructose vary with temperature, and they vary with variety.
The ratios of them, yes, to some extent they do. And I am making a general statement when I say across our grape varieties, they are present approximately in a 1-to-1 ratio. But they are going to differ. What we're looking for, of course, anxiously, is more detailed information on all of the main varieties going into detail like this. Actually, there have only been a very few where the detailed information has been brought forth pertaining to all of the individual sugars and the different organic acids as well. And we certainly want all of them before we can say we've got a reasonably complete picture of the change in chemical composition with maturation. You had a question.
Yeah, how does irrigation affect the other constituents other than just the...
Well, if the irrigation program is such that the vine doesn't go into severe stress at any time, it probably has no particular dramatic effects on them. But when you get into stress, of course, you can have other things happen. Now, what specific...
To prevent any sort of fluctuation, like a drip irrigation system?
Well, to really critically control the water, some operators actually use these tensiometers in the vineyard. And they are very helpful. But they also can be misleading unless the man knows his vineyard well and knows his soil, because that instrument represents this area right here, under my foot, so to speak. And those of you that are familiar with soils know that they can vary tremendously, just short distances. So you have to take this into account, the variability that, here again, what's your sampling error, you see, in the tensiometer's location. Hard pan, hanging water tables can drastically affect the water conditions from one point to another in a vineyard, and points real close together. Now, I don't know whether that answered your question or not. Okay. Yes?
I heard it says that when you have a rain, like at the end of the season, and your grapes are just ripening, the lenticels of the grapes can absorb water directly in the grapes. Is that true? And that upsets your balance.
I question it, but I have no data on which to refute that comment. We know that grapes can exude, or rather leaves, not grapes so much, exude water called guttation from the ends of the fibrovascular strands. But I don't know as to whether that's real or not. But there is definitely, can be, a slight dilution effect because of the influx of water through the normal translocation channels. Any other questions on that particular transparency then? Well, we can always come back to it. Now let's move to the one pertaining to the acids. If I could get you to put that up there, I'd appreciate it. We may have to take these one at a time. I don't think we can get them all in. That's fine. Thank you. Is there anyone that does not have the handout pertaining to this transparency? Okay. Over in the corner. You may have to look around it. But we have to have that machine up there for obvious reasons. Now, in this case, for convenience, we do have the period, a blooming period indicated, as well as the fruit set. And as I said yesterday, this is a very critical period in the vine from the standpoint of respiration and the synthesis of compounds, as well as their, of course, respiration degradation. Now, during the bloom, then, we have this synthesis. This is in percent, so it would be percent by weight of the acid. In this case, it's the tartaric, no, malic. This will be the fruit. Change the fruit now. Oh, excuse me. These in here are the forms, the cluster form, I should say. In other words, the flower form, using the, well, what they are, they're actually the little form. It's the only thing you have to work with, which does include the flowers and the stems, what will be the pedicels, and even the rachis and the laterals. Yes, right. Mm-hmm. I should have mentioned that. I'm glad you brought that point up. And then it's at this point that you are now restricting your analysis just to the fruit itself. That could be a reason for this sort of anomaly in here. And then at fruit set, of course, your berry enlargement stage is here. You have a very rapid increase for a short period of time. In this particular case, it's the malic acid reaching a peak in the case of Thompson seedless along about the mid-July, or no, it'd be in June. It's unfortunate that we don't have the berry size on this superimposed. I'm going to try and remember to do that because we're not as far along in the season as it looks here. The berry enlargement is over in this area here, beyond that. But at any rate, those very small berries have this very high level of total acid, in the order of almost 2% here, of which most of it is represented in this case early by the malic acid and then some tartaric. But then they change as you progress through the season. Now, at this point, berry enlargement is proceeding very fast. The percentage is going down, not necessarily the absolute amount per berry. It isn't until you reach at this point in here where there actually is a decrease in total amount of titratable acid in the berry, on a per berry basis. We have to be very careful about these percentages and absolute amounts, because this would indicate that the vine is no longer making it as fast. Well, that's not necessarily true. There's a strong dilution effect here because of the increase in the berry size. But over in this point in here, essentially from here on, as your berry has reached full size, then there is generally a decrease in the absolute amount of total acid in the grape berry. And this, of course, is due chiefly to respiration and Thompson seeded, notably a high in tartaric acid grape at maturity. The malic acid is respired to a greater extent than the tartaric. In fact, it always is. In this case, Thompson retains its acid under hot conditions better than some varieties, and the main reason is because it does have an appreciable content of tartaric acid. Now, yes?
Why does it drop just after fruit set there?
Well, let me explain the anomaly here. The analysis in this particular phase up through until fruit set was based on the entire little flower cluster. About all that in fact this is Cleaver's work, about all he had to work with. But then at this point, with those berries that are about the size of BB shot or buckshot, then he had enough fruit to work with so that he could secure a valid sample to actually measure the acid of the fruit itself. So you do have stem tissue, for the most part, involved in this here. Is this what you were puzzled about?
No, I was asking why is it dropping in the stem tissue? Is that due to...
Well, that's true actually. Well, here you have your rapid enlargement of your stem structure you see in here. They're increasing very fast. There's a dilution effect there. It's interesting. There's a lot to be learned right back in this period. Dr. Hewitt down at the Kearney Station has been puzzled about this problem with Botrytis Rot on grapes, wine grapes as well as raisin and table, where there are many infections that seem to appear in the summer towards maturity. Botrytis, and certainly there hadn't been any rain to encourage the growth of it. And the thought is that it's back in this stage here where the Botrytis spores in the spring can germinate, get a slight start in the dead or senescent flower parts. And this, of course, is a common place where Botrytis will get started. The petal tissue and things like that are very good media for Botrytis if there's enough moisture. So in the spring, if there is enough moisture for this to happen, then his hypothesis is that the Botrytis grows to a certain extent and then remains latent or dormant. And then later in the season can actually further invade and actually infect the berry. Now, the question is, why would it become latent? His theory is that the acid increases very suddenly right at this bloom period. The pH goes down, and the theory is then that it's an unfavorable medium in which the Botrytis can grow any further with this very low pH. It gets started actually in pHs back in here that are higher than they are right about fruit set or a little after. And then, of course, later in the season, as the dilution effect sets in and even a loss of acid, the pH again rises so that it would be a favorable medium for the fungus. I just mentioned this as a theory that there is data that supports that theory. And again, it's the interplay of these acids in this berry all the way through the season that appears to may have a role in this particular problem of decay. Are there any further questions? Now let's move up to this one, if you can slide that for me, please. All right, Carignan. Now we do have a little help here. We have the degree bricks superimposed. I suppose I should have taken this one first. But at any rate, here we have this anomaly, of course, of the acids right at the beginning based on the cluster, the flower cluster forms. A fantastic increase right here, and this should be interpreted that it actually went to 1.9%. Now this is 1.6, so this point would really be located somewhere up about in here. And then a rapid drop with your dilution effect of your stems and so forth. And then at this point, we take off with the fruit itself rather than the cluster or the flower cluster forms. You notice here you have a lot more tartaric than malic here in this particular variety, back in the cluster forms. And then when you get into the fruit itself, they are about equal and remain so roughly clear on out through to the end of the season. Now, the relative rates of these dropping is, of course, going to be influenced by temperature. The hotter the temperature, of course, the greater the tendency for the melic to drop as compared to the tartaric. And then, of course, the amount of crop on the vine, if it's heavy and you have to move farther into the fall season in order to get this Brix up to a respectable level, then, of course, your acid is going to continue to drop. And if it's hot, then, of course, this will further accentuate the difference between the tartaric and the malic acids. Now, are there questions here at this point?
Where were the vines growing that you studied? Was it a single vine or a block of vines?
No, he worked for different vines, but I think these were Davis vines. I'm quite sure. I'll check on that and see, but I think it was. Now, the effect of, I mentioned overcropping. If, for example, this vine, let's say it had the crop was well within its capacity. In other words, it could mature the fruit at a normal rate up to the level you see here. Now let's assume this vine had too much crop on it, and this, of course, is something that happens particularly in heavy soils where you irrigate and you're going for the heavy tonnage, which, of course, if you're growing the grapes for table wines, this can be a real problem in trying to have your cake and eat it too, where you're concerned about this total acid. But in that case, what would happen with a heavy crop, this sugar would come up at a slower rate, of course moving across the time abscissa, and maybe move up something like this. And if you ever did get to 24, it'd be out here maybe another week or two later, although I doubt, considering October, that you're going to do very much ripening of your vines after about the 1st of October. It just isn't in the books to get normal ripening in our conditions here much after that. There are exceptions, but by that time, the leaves are quite senescent. You usually don't have the temperature in which you can get any reasonable amount of photosynthesis. Let's assume then that you have it come out here at a low level of sugar. Then, of course, in the meantime, your acid is going to continue to go down. Your ratios of sugar to acid get higher and higher. And what's worse, they get higher in spite of the fact that you have a fairly low Brix. And you have then a very thin type of juice. Yes?
The slope then on your sugar line would be more gradual, right?
In the case of an overcropped vine, yes. It, in effect, would be probably, if we stayed on the same time scale, this would come up along about, maybe top out somewhere up in here in a heavy crop vine. And your acid would continue to go down.
Would your slope on your acid curve become more gradual too?
No, it's more dependent on the temperature than anything else.
Your acid doesn't decrease, or just the rate?
How's that?
The quantity, total quantity of acid doesn't decrease?
It's decreasing in this stage from roughly about here on.
But it's not any less than normal cropping?
No, the cropping doesn't have much impact on the acid content, except as it delays the harvest period. And your fruit then is exposed to these respiratory conditions that respire away the acid. So it's the delay in harvest. And of course now with table wines, we're very concerned about this total acid content. Do we have to wait until October the 9th to harvest this fruit in order to get a reasonable balance of our sugar and acid, or at least get enough sugar? Or can we harvest back here someplace if by proper cropping we can steepen this accumulation of soluble solids and harvest at an earlier date and at a higher level of total acid for a better balanced table wine? Now, there are things besides just controlling the amount of fruit on the vine that will determine what's the capacity of that vine. There is, of course, first, how much fruit it has, but that amount of fruit is in relation to the leaf area of the vine, and further, how that leaf area is distributed and exposed to the light. So you could very well have a given number of pounds of fruit on the vine and would be overcropped under an unfavorable trellising system, for example. On the other hand, with favorable spreading out of the vine, then it may well be a normal crop. And again, get this benefit even at the same tonnage. So when we speak of overcropping, we have to look carefully at what is the factor, or what are the factors that put that vine into an overcrop situation. Overcropping, the level is arbitrary, but I might state that Winkler's interpretation of when a vine is normally cropped is that it will bring that fruit to the maturity at the time you want it and a balance that is for the use for which it's best intended. Now, it turns out with vines, as you increase the crop, you do not delay harvest until you reach a certain point. And then there's a rather sharp break where you then start to delay harvest progressively. If, for example, you wanted to have fruit for 24-degree Brix, and you had a series of vines here, let's say of equal vigor. This vine is pruned to say it'll mature 20 pounds of fruit. This vine 30 pounds, this one 35. Perhaps there is no difference in the date at which the 10 and the 20-pound vines, or even the 30-pound vine, may reach 24 Brix. But perhaps you step over that line, that level of tonnage, into 35 and 40 pounds, then there may be an appreciable delay. That is an overcrop vine, at least under that set of conditions. Yes?
What about the other constituents in your grape, your flavor constituents and things like that? Are they the same?
The what?
Flavor constituents.
The flavor.
Yeah.
I have a transparency on that. If you...
I'll wait.
You want, all right. I don't mean to duck it. Usually if I don't know the answer, though, I'll admit it. But we'll take that up next. Are there any further questions now? As I say, we can come back to this if you'd like, but right now this gives us, hopefully, a little better picture of the interplay of the different types of organic acids, at least the two main ones. Now, of course, we have other organic acids, and we will go into a little more in detail on those later, but right now let us consider the two that are about 90% approximately, account for about 90% of the total acid in the grape. Let's see here, if I could I bother you to pass out 5 sheets to each row there, please? I think it's 5. Is there anybody with 6? No. The picture as near as we can. It's rather interesting in the biochemistry of the synthesis of the various acids. Tartaric acid is a somewhat unusual organic acid in the plant kingdom. The grape is not unique in being the only one by any means, but it certainly is one of a very few of the plants in the animal kingdom that does, plant kingdom, that does synthesize tartaric acid. Now, this becomes particularly interesting when we look at the pathways by which these acids are synthesized. And by the way, I'm not going to expect you to know the Krebs cycle by any means. I couldn't sit down and put it all together myself right now. I'd have to do some reviewing, I would be frank with you. But the tartaric acid is not involved in this so-called Krebs cycle. It appears now that the tartaric acids evolved up here through this particular chain of events here, not involved in the Krebs cycle at all, in order to form the very familiar tartaric acid. Now, the malic acid it's a part of this little whirlpool of acids such as succinic, glutaric, ketoglutaric, malic, citric, and so forth. As the H ions are taken off and on, and even the carbons, through this so-called respiration cycle, or the Krebs cycle, which is a cycle where most of this energy appears from the breakdown of your sugars initially and finally into your organic acids. So this is a proposal for how the tartaric acid is formed. And then this over here, as a part of the Krebs cycle, the synthesis of the malic acid. Now I do have some handouts. I'll see how our time goes next week on the overall biochemistry, which puts this into that whole whirlpool of the Krebs cycle, and you can see how that operates in case you're not familiar with it already. But I'm trying to bring in just the main points along here now as time permits. Now, are there any questions at this point on these two particular acids? The take-home point, as far as I am concerned, is that we do have an unusual acid here in the plant kingdom, in tartaric acid in grapes. And it does not originate in or is involved in the Krebs cycle. They can make a very positive statement on that. Very likely it originates here in this breakdown, phosphorylation of the glucose to form, through this pathway, the tartaric acid. The malic acid is in the Krebs cycle, the so-called normal glycolytic cycle, and it is in this cycle where the malic acid appears. Yes? I can't give you a good answer on it. This is a little sketchy for my rather elementary biochemical background.
Happens to the two hydrogen fragments?
No, I really don't. I really don't. And what we'll do, if we have time, we'll go back on some of the other graphs and where there's a lot more detail on that and see if we can answer it. But I don't have a good answer for that, frankly. Are there any other questions? Yes.
Tartaric acid at the very beginning of flower growth increased dramatically up to about 1.9% total solution. Was this catalyzed by some enzyme that suddenly disappears or is inhibited at that point, and then the glucose goes to glucose remains in solution instead?
Well, certainly is enzymes that are involved, the catalysts in each one of these stages. Some of them are very, very specific. In fact, most of them are. Now, as your question as to is there an inhibitor that has stopped or put a brake on that, I don't have an answer for that one. I don't know. There is that anomaly, though. Let me repeat it. Those curves at the first were based on the tissue of the entire flower cluster or cluster versus as we got into the pattern later on just the fruit itself. Are there any other questions now pertaining to the two basic organic acids that we're concerned with? I don't have such detailed data on the succinic acid or the citric acid, which also appear in grapes, particularly the citric. Maybe the biochemists will come forth with that in the near future. But again, when we're dealing, we've accounted for about 90% of it up here. We're pretty well along the way when we just have the malic and the tartaric. Now, in the amino acids, this, of course, as a virtue of what transamination to get the nitrogen into the cycle, forming particularly proline. Here we have the end of August. So you don't have much of this form, these amino acids, until you get over later in the season. Arginine, proline, threonine, and serine. These four are the main ones that they have focused a little of their attention on. This happens to be in Cabernet. Now, of course, your scale here, milligrams per liter. So this is quite a different scale than we're looking at when we're looking at tartaric and malic acid. But nevertheless, they're very important. They are cursed by the enologist sometimes under certain conditions and blessed under other conditions, depending on whether you want nutrient for the yeast or whether you want to clear your wine. And so it depends a lot on the situation. But they are there, and any knowledgeable enologist is going to be concerned about them. Now, if we can raise that transparency a little bit, this gets a little bit more into the detailed pathway. This is the photosynthetic formation of serine, glycine, and alanine. And it simply shows the pathways, which I certainly am not going to expect you to know, but I simply include them to give you a little better picture of the rather complicated pathway by which these amino acids are formed. They, of course, are the main constituents of the cytoplasm of the cells. That's where they're located particularly. And the concentration of them in a fruit is fairly low because it is not meristematic tissue. It's gotten its size by virtue of cell enlargement, and the actual amount of cytoplasm in a cell, a big pulp cell, is not much different than it was as a cell 100th of that volume earlier in the year. Are there any other questions on this? Well, I'll tell you what I have. We have one more transparency here. If you want to take 5 or 10 minutes, we can put the transparency on pertaining to the phenolic compounds. We may not be able to develop this all, but if you have the time, we'll take a quick look at that.
Can we cover it next week?
We can.
Would it be easier when rushing it?
I'm debating. I hate to get halfway through. Let's cut it off there then. We'll start next time with because I can anticipate quite a few questions and discussion in that area. So maybe we better not get involved in that. Now, if you'll hold it just a minute, please. There was a question, yes?
Is a high concentrate relative concentration of proline unique to Cabernet, or is that
I don't know whether Cleaver is prepared to make a general statement across other grape varieties with that same magnitude or not.
It's generally true with most of the grapes.
I think it is, but I don't want to make the statement because I'm not sure enough of it to know. You could ask Cleaver. I'm sure that he's probably got enough unpublished data to make a much more conclusive statement than he'd be prepared to here.